Alright, welcome back everybody. So today we're going to be talking about section 2.1, solving first degree equations. And we're going to start off with talking about what a degree is. So a degree is the highest exponent of the equation. And the next thing we have here is the addition property of equality. So for all real numbers a, b, c, a equals b if and only if a plus c, so a plus c is equal to, it has to be equal to b plus c. And remember, this case is only true if a equals b. So the next thing is the multiplication property of equality. For all real numbers a, b, and c, where c is not equal to 0, a is equal to b if and only if ac equals bc. So basically what if and only if is that if this is true, then this is true, and if this is true, and if this is true, then this is also true. So it has to work both ways. That's basically what it's saying. Okay, so let's move on to our first example. So example 1. Solve solve, and then it says 4 times y minus 1 plus 5 times y plus 2 is equal to 3 times y minus 8. Okay? So we're going to start off by using the distributive property actually. And so we're going to do 4 times y minus 1, or 4 times y, which is 4y, minus 4 times negative 1, which is negative 4. And then we're going to do plus, and then 5 times y is 5y, and then 5 times 2 is 10, which is equal to 3 times y, which is 3y. And then we're going to do 3 times negative 8, which is negative 24. Okay, so now that we have our equation, we are going to simplify the left side so that it's a little bit easier for us to solve. So we're going to do 4y plus 5y, which is equal to 9y. And then we're going to do negative 4 plus 10, which is equal to positive 6. And then we're going to put the equal sign, and then we're going to have 3y minus 24. So in order to bring the y's on one side and the numbers on the other side, we have to subtract that number so that we have to subtract or add that number depending on whether it's positive or negative, in order to get rid of that number from one side and put it on the other side. So in this case, we have 3y over here. In order to get rid of it, we would just do we would minus 3y from both sides. I can't do the negative 3y here. Here, let's do that. And then plus, and then minus 3y over here. And then that would cancel out the 3y's on this side and add a 3y over here. So same thing we would do for the 6. If we wanted to bring the 6 over there, we'd do minus 6 over here, and then we do minus 6 over here as well. So now let's do that, and when we do that, we get 9y minus 3y, and then negative 24, oh no, not negative 24, we get equals negative 24 minus 6. So we have 6y is equal to negative 30, and then we have y is equal to negative 30 divided by 6, which is equal to negative 5. Okay, so example 2. The sum of 3 consecutive integers is 13 greater than twice the smallest of the 3 integers. So we need to find the integers. We need to find all the integers. So if it's consecutive, first we need to find the smallest integer. So we're going to say the smallest integer is equal to x, which is the first integer. Okay. Hopefully I spelled that right. Okay, I did. Okay, so then the second integer is going to be x plus 1, since it is consecutive, which basically means you're adding 1. If it was every odd consecutive number, then you would be adding 2 because it's every odd number. So say you have, so just assume that x equals 1. Then if it's saying odd, you would just add 2 in order to get the next odd number. But if it's just consecutive, you would just do 1 plus 1, which is equal to 2. There you go. Okay, so x plus 1 is going to be our second integer. Oops. Integer. And then x plus 2 is going to be our third integer. Okay, so now remember that they said that the sum of the 3 consecutive integers is 13 greater than twice the smallest of the 3 integers. So basically what that means is that all of these, so the x plus 1, x plus 2 added together, let's just so x plus 1 plus x plus 2, all of that added together is equal to 13 plus 2 times the smallest integer, which is going to be x in our case. So now let's simplify the left side of the equation, and we get, and when we add up the x's, we get 3x, and then when we add up the numbers, we get plus 3 is equal to 13 plus 2x. So now we're going to subtract 2x from both sides, and we're also going to subtract 3 from both sides, so that we can bring the 3 over here, and then bring the 2x over there. So 3x minus 2x is equal to 13 minus 3. And then now we're going to simplify. We're going to get x equals 10. So then our first integer is equal to 10. Our second integer is equal to 11. And our third integer is equal to 12. So one way we can check whether this is right or not, we can basically plug it into like this information that we were given. The x plus 1, x plus 2 is equal to 13 plus 2x. We can basically plug it into that, and then we can find out whether this is real or not. So we have 10 for the first thing, and then x plus 1 is equal to 11, x plus 2 is equal to 12, is equal to 13 plus 2 times 10, which is 20. Okay, so 10 plus 11 plus 12 is equal to 33, which should be equal to 13 plus 20, which is equal to 33. So therefore, we know that our consecutive integers are correct. Okay, so moving on to our third example. So Kwa received a car repair bill for $412. This included $175 for parts, $60 per hour for each hour of labor, and $27 for taxes. Find the number of hours for labor. So we're going to highlight our important information here. So we know that his total bill was $412, okay? And what it was made up of was $175 for parts, $60 per hour for each hour of labor, and $27 for taxes. So we know 2 of the things, but we don't know how many hours they spent for the labor. Okay, so now we need to find that out. So let's say the amount of hours for labor was x, okay? So we're going to have, let's do 175 plus 60x, okay, 60x, and then plus $27 for taxes, which is equal to $412. Here, let me zoom in. $412, okay? So now let's add up 175 and 27, and then we get 202 plus 60x, which is equal to 412. Now we're going to subtract 202 from both sides so that we can eliminate this and then add a 202 over there so that we can have the variables on one side. So we're going to do, now we're going to have 60x is equal to 412 minus 202. Okay, so 60x is equal to, so 412 minus 202 is equal to 200 and, let's see here, 210, okay? And then we have x, so we're gonna divide. Okay, yeah, so I forgot to mention in my previous examples that when you want to get rid of the number that's right next to the x, you want to divide both sides by the number that's next to the x. So then you would get 60. So you would divide both sides by 60, and you would get 1 over here, which is the same thing as x. 1x is equal to x, is equal to 210 over 60. Okay? And now what you can do, since we have two zeros, or we have 1 0 over here, you have a 0 on the edge over here and a 0 on the edge over here, we can just cross them out. Basically, the zeros don't matter anymore. So now we have x is equal to 21 over 6. Now we need to turn this into a mixed number. So in order to turn it into a mixed number, all you have to do is see how many times 6 can go into 21. So if we do 6 times 4, we get 24, which is too much. If we get 6 times 3, that's 18. So the smallest, or the biggest number that goes into 21 with 6 is 3. Now what's your remainder? We know that the remainder when you divide 21 and 6 is 3. So now all you just do is do the remainder, which is 3, and then divide it with what you're dividing by. So that would be 3 over 6, which is equal to 3.5 hours. If you want to rewatch that again, you can just go ahead and rewind and then watch it again if that was confusing. But otherwise, that's going to be the end of this lesson. The problem set for this section will be in a separate video. If you need any help, contact the email that I have on the display. Otherwise, I hope you have a great rest of the day. Thanks for watching.